triangular distribution is a distribution model that, while there is times when it theoretically exists, it's often actually useful in times when it's not so much, not the right model, but it's a good estimate for lots of different models. The way we calculate a triangular distribution is to think about the probability density function, and we can calculate the area under that. So it works in a situation where basically the probability increases uniformly from the minimum, which we call A, to the maximum, to the mode, which is C, and then decreases uniformly from the mode to the maximum, which we call B. Right, and the function of a probability the probability density function for a triangular distribution looks like this: f of x equals starts off with 0 when x is less than a. Right, that should be pretty straightforward. When it's less than the minimum, it doesn't exist. Right. The next one, and we can go through the algebra for this, but I'm not going to do it here. We've got two lots of x minus a all over b minus a, c minus a. And this is when x is between a and c. Right. We put less than or equal to, but actually at C or A it is 0. Right. And then we look at 2b minus x over b minus a, b minus c. And then this is between c is less than or equal to x, less than or equal to b. And finally 0 where x is greater than b. Again, obviously because there's nothing bigger than the maximum. Now that looks really complicated and really difficult. And what you need to do with this one is once you start putting it into numbers, it all works out a whole lot easier. So the first thing we do, if we have a situation where we do this, we think about applying our numbers to the density function. Alright, so let's say we had one here where this was 1, that was 3, and this was 5. Okay, so here we have A equals 1, B equals 5, and C equals 3. The first thing we're going to do is we're going to write an individual density function for this. Right? So f of x equals, well, it starts off 0 where x is less than 1. Then if we look back at our rule here, we've got 2 brackets x minus a, 2 brackets x minus, and a is 1, all over b minus a, so it's 5 minus a, which is 4, times c minus a, which is 2. And that's between 1 is less than x is less than 3. Right. We look at the next part of it. Two lots of b minus x, which is 5 minus x. Let's just tidy that up. 5 minus x all over b minus a, which is 4, times 5 minus 3, 2. Alright, and then that between 3 is less than or equal to x is less than or equal to 5, and 0 where x is greater than 5. Okay. So in this one here, if we wanted to find the probability that x is greater than 4, well, we've got to think about where does that 4 lie. Well, 4 is in this range here, where it's between 3 and 5, so therefore we need to use this equation here to find our height. All right. So f of x equals 2 lots of 5 minus 4 all over 8. So our height, f of x, equals 2 lots of 1 over 4, which is 1/4. Now, this is where it gets kind of useful, where we now need to think about what have we actually done here. So I'm going to draw a little graph. Alright, and so we have 1, 3, 5, and 4, and we're wanting to know this area here. Right. So we know that the height of this triangle, which is what the f of x part is 1/4. So we're going to zoom in on this triangle here. We've got a height of 1/4, and we've got a base of 5 minus 4, which is 1. Right. So our area of the triangle, 1 times 1/4 all divided by 2. The area equals 1/8, and we know that with the density function, the area is the probability. So the probability x is greater than 4 equals 1/8. Okay, let's have a look at another example. Okay, so here's a situation. We have Christina who's waiting for a taxi. She knows the shortest possible wait is 2 minutes, the longest she'll have to wait is 10 minutes, and the most likely wait time is 4.5. Find the probability she has to wait less than 6 minutes. Okay, so first of all, we're going to draw a graph of this. We don't know if this is triangular or if it's some other model, but with all the information that we have says that triangular is the best model to use. So we're going to draw our equation. It's going to look, so our probability density function is going to look something like this. 2, 4.5, and 10. And we want to know the probability she has to wait less than 6 minutes. So our x is going to be 6 here. Now, we could work out what's to the left of that, but in this case here, we want to find the probability that x is less than 6, which is going to be equal to 1 minus the probability that x is greater than 6. Right? And that's going to be our triangles. That's going to be a much easier one to work out. So what we need to do first of all is create our probability density function. Right? So we're going to do that. We know that f of x right, 0 when x is less than 2. Alright, now it's 2x minus a. So 2 lots of x minus a. And our a here, of course, is 2. Over b minus a. So that's 10 minus 2. 8. Times, and then we've got c minus a, which is 4.5 minus 2. So that's 2.5. And that's between 2 is less than x is less than 4.5. Now we need a little bit more room here. Right, the next one we have 2 lots of b minus x, 10 minus x, all over b minus a, which is 8, times b minus c, which is 5.5. That's between 4.5 is less than x is less than 10, and then 0 when x is greater than 10. Now you can put the equal to signs on here if we want to. It doesn't really matter because it is 0 when it equals on equaling any particular number because it's continuous. All right. So we've got that now. Now we need to think about, well, Where is our dot? It's between 4.5 and 10, so it's in this range here. So our density function is going to be f of 6 equals 2 lots of 10 minus 6, which is 4, over 8 times 5.5, which should be 44. It is 44. Right, which is going to be 2 over 11. So then we draw our triangle. We know at the bottom it's 10 minus 6, which is 4. And our height is 2/11. Area equals base times height divided by 2. So here, area equals 2/11 divided by 2, which is 1/11 times 4, which is 4/11. Right, and if that's the area, then also the probability that x is greater than 6 equals 4/11. So the probability that she'll have to wait less than 6 minutes is equal to 7/11. And that's really how it works with the triangular distribution. It looks really complicated, but once you start putting the numbers in, it works out to be a lot easier than you'd think. Now, sometimes you get ones that require doing a trapezium, but again, you just find the height on both sides and you use that as your A and B. The big thing with it is to actually draw the picture, think about what's happening, and then solve it. If you try and just jump into solving it without drawing the picture and thinking about what's happening, you're asking for trouble.